Afternoon. So in this video we're going to be looking at something called composite functions. Composite functions is the composition of two functions or many functions. It's the combination of functions. Okay, so for composite functions we're going to take some input, we're going to put it through several functions, normally two of them. So we're going to put it through several function machines, one after another. Okay? So take some input, put it through one function machine, take the answer, and put that answer through another function machine. So we could take this function. Let's use the notation for the function machine notation. F of x, let's say, goes to 3x minus 1. So the function f takes the input and times it by 3 and then subtracts 1. The function g takes an input, squares it, and then multiplies it by 4. Okay? So using the other notation, we can say f brackets x equals 3x minus 1 and g of x equals x squared times 4. Lovely. So, a composite function, f g of x. Okay? So, this means that x will go into g, and then the output from this, the answer, will go into f. So x will go into g, and then that answer will go into f. So f g of x, x goes into g, and then that answer goes into f. We'll do some examples to hopefully make this idea clearer. Let's look at f g of 1. So 1 will go into g. When you put something into g, you square it and you multiply it by 4. 1 squared is 1, 1 squared times 4 is 1 times 4, which is 4. So when you put 1 into g, you get an answer of 4. Now the composite function, fg of x, or fg of 1, you put 1 into g, and then you put that answer into f. So we're going to take that answer of 4, and we're going to put it into f. So we've taken 1, we've put it into g, and we've got 4, and now we're putting 4 into f. When you put 4 into f, you times 4 by 3, and you subtract 1. So the answer would be 12 minus 1, which is 11. Okay. So just to go through that again, you take 1, you put it into g, you get an answer of 4, then you take that answer 4, and you put it into f. Okay, let's look at a different example, fg of minus 3. Maybe if you're happy with this concept, you could pause the video now and see if you could do it yourself. So, we put minus 3 into g, well that's 4 times minus 3 squared. Minus 3 squared, minus 3 times minus 3 is 9. 9 times 4 is 36. Now we take this answer, 36, and we put it into f. So we put 36 into f. When you put 36 into f, you do 3 times 36 minus 1, which is 107. Okay? So let's take that idea and just clarify it looking at function machines. So the first one, we took 1, we squared it, we times it by 4 to get us an answer of 4. Then we took this output, and we put it into f. When you put 4 into f, you times it by 3 and you subtract 1, and this gives you the final answer. So that's kind of related to the first bullet point where I said you take an input and you put it through several function machines, one after the other. Okay, let's look at the composite function fg of x. So this time we're kind of going more abstract. We don't have an input. The input is x. So if we put x through the function machine g, the output is 4x squared. Then we're going to take 4x squared and we're going to put 4x squared through f. We take the output and we put it through f. So when we put 4x squared into f, well, what does 4x squared do? What does f do to 4x squared? Well, the function f multiplies the input by 3 and subtracts 1. So we're going to times it by 3. Timesing 4x squared by 3 gives us 12x squared, and then subtract 1 gives us 12x squared minus 1. So when you put x into the composite function f g of x, you put x through g first. When you put x through g, you get 4x squared. Then you take that output 4x squared and you put it through f. Putting 4x squared through f multiplies it by 3 and subtracts 1. So this means that the composite function f g of x is really just 12x squared minus 1. I hope you're still following. Okay. Using other notation, so using the alternative notation, we could say f g of x is really just taking g of x and putting it into f. G of x is 4x squared. When we put 4x squared into f, we times the input by 3 and we subtract 1, giving us this. Okay, now, it's also worth noting at this point that f g of x is different to g f of x. G f of x means you put x through f first and then you put that output through g afterwards. You do things the other way around. So x goes into f and then into g. Okay, so when we put x through f, we get 3x minus 1, and then we put 3x minus 1 through g. 3x minus 1, well, what does g do? It will square it and then times that by 4. So we're going to square 3x minus 1 and then multiply this by 4. So gf of x is 4 brackets 3x minus 1 all squared, which is different to fg of x, which was 12x squared minus 1. Okay, let's look at the same thing through function machines because I think that's easier. When we put x through f, we get 3x minus 1. Now we take 3x minus 1 and we put 3x minus 1 through g. 3x minus 1 will square it, and then it will multiply that by 4. Okay? So this is a basic, or an introduction to composite functions. We're going to look at more composite functions in lessons. I hope you followed most of it, and we'll get more practice this week and next week. Thank you for watching.